Hi, I'm Toby Swan at pptx.com, and this video is going to be about energy resources, in particular renewable resources. We'll look at another video after this on non-renewable sources. So what we'll cover, the main uses of different energy resources generally, then the difference between renewable and non-renewable energy resources, and then we'll go through a number of different renewable resources and compare them, evaluate them as their pros and cons. So what do we need these energy resources for? What do we use them for? There are three things you need to be aware of. The first one rather, is transport. Obviously, aeroplanes, cars, getting yourself from one place to another, carrying cargoes, carrying resources from one place to another, whether that's by lorry, by boat, by plane. Transport, massively important. Heating, keeping your homes warm, keeping your schools warm, keeping factories warm, keeping everything warm and comfortable. Very important. But the thing we will probably spend most time in this video looking at is electricity production. Okay, electricity, of course, undeniably hugely important in modern life. Everything we use pretty much requires electricity. So where does that electricity come from? You plug it in at the wall. Doesn't just come from nowhere. Energy cannot be created or destroyed. That electricity, that energy has come from somewhere. So that's what we're going to look at, where that electricity has come from. To produce that electricity, there again, another video which will come later on electromagnetism. The process by which electricity is produced is actually quite complicated and a little bit different. We'll cover it, as I say, with electromagnetism. But basically what you need in most cases, not always, but in most cases, is something to move. Okay, so a lot of these processes, I'll be describing how we make something move, and that kinetic energy will turn a turbine. In turn, that will turn a generator, a moving magnet or a moving wire within a magnetic field, and that produces electricity. And then that's carried across the national grid in the UK. Before we look at that, though, we need to know two really important things: the difference between renewable and non-renewable energy sources. So definitions, get these down, they're in green, so make sure you write these down or know them off by heart. A renewable energy resource is one that will not run out or can be replenished over a short period of time. That's a little bit open to interpretation, but short period of time, generally 20, 30 years, if you can renew it within that time, that's generally considered renewable. As a general rule, but not always the case, but bonuses of them being renewable: first of all, they're not going to run out, but also they do not produce radioactive waste. Most of them, not all, but most of them do not produce greenhouse gases like carbon dioxide, and most of them do not produce gases that will cause acid rain like sulfur dioxide. Of course, I say in brackets there, at the point of energy production. Of course, all these things require transportation. When you're getting the fuels there, when you're moving back and forth, those cars or those lorries or those aeroplanes carrying what's required will probably produce greenhouse gases and acid rain. But at the energy production themselves, in the power stations, if you're using renewable sources, they generally do not produce those gases. So things like wind, hydroelectric, wave, tidal, solar power, geothermal, those are the ones that do not produce those harmful gases. Biofuel is also considered a renewable resource. We'll look at that as well, but that does produce those gases, so it's slightly different, biofuel. A non-renewable energy source is one that is finite. It will run out. It cannot be replenished. More specifically, it cannot be replenished once it's been used. Things like coal, natural gas, oil, they take millions and millions of years. Of course, ultimately, eventually, they would be replenished, but they will take millions of years. So we're talking about things that can't be replenished in a sensible timescale. We're talking again 20, 30 years. So fossil fuels, as I said, coal, gas, oil, uranium, which is used for nuclear power stations, they are all non-renewable. We can't produce them within a short time period. And they also tend to produce harmful gases, greenhouse gases, the gases I talked about before, sulfur dioxide for rain, the carbon dioxide for greenhouse gases, but also radioactive waste. So as I said, what we want really, in most of these cases, we're going to produce our electricity, is what we're mainly talking about, and to produce our electricity, we generally need a generator. Okay, the generator is pretty much, it's going to include a magnet that's spinning around within some wires. And for reasons that we'll talk about when we're looking at the electromagnetism topic, that will generate electricity. Usually generate an AC, an alternating current. So what we're going to talk about mostly in this video is how we get that motion. Okay, how do we get the motion that ultimately is generated into electricity? Okay, so the first one we'll look at is wind power. And this is really straightforward because wind obviously is moving already. All you have to do is get that wind to move a turbine. So you have pretty much a windmill. We've had these for hundreds of years, wind farms, we've had windmills for hundreds of years, but rather than getting them to grind corn, we're now going to get them to turn and generate electricity. But the process, not massively different, it's just that you've got a generator in here. You don't need to know the details of this, but just so you can see what's going on here, you generally have a shaft. The wind is going to be turning those blades. The shaft will have a gearbox and it will turn a generator, and that generator, as I said, will produce electricity. So what are the energy changes, which you do need to be aware of? Think back to previous videos. The energy stores, well, the wind is kinetic and it's directly turning that kinetic energy into electrical energy at the generator. So that is direct. Yeah, it's going straight from kinetic to electrical. The advantage of this, as we've kind of touched on already, it's a renewable resource, as are all of the ones in this video. Therefore, there are no greenhouse gases. It's not going to produce carbon dioxide. No acid rain. It's not going to produce sulfur dioxide. No radioactive waste. Fairly inexpensive to build, and a short startup time. By short startup time, what I mean is that it can create electricity very quickly. If you decide you need electricity, it doesn't take long to get it going. Okay, pretty much immediately. The disadvantages, however, are that it's unreliable. Okay, it needs wind. It's not always going to be windy. There are going to be certain areas that it's going to be much better suited to. Okay, you need places that are windy. Often in the countryside, you don't necessarily want to ruin the view, and these windmills are often regarded as unsightly. You can put that out at sea, but again, a lot of people want to have a look at the ocean, not disrupted by a farm of windmills. You need a lot of them. So it kind of links to the previous point. You're not just going to have one windmill. You might have one for a farm or something, but generally if you're trying to give electricity to a town, you're going to need a very large area of windmills. So it takes up a lot of land. If you live close to them, they also can be a little bit noisy, kind of humming noise. Okay, the next one we're going to look at, the next energy resource we're going to look at is hydroelectric power. Very similar process in terms of the energy transfers. What you have basically is a river, and you build a dam like this. This is the dam that's been built, and it produces a large reservoir, a lake. That water then can be controlled, and it will flow through the dam to the turbine, to the generator, and that flow of water will then continue along the river, but it's that flow of water, that kinetic energy, that is turning the turbine and then the generator producing the electricity. So what are the energy transfers here? Well, obviously we're getting kinetic energy turning the turbine and creating electrical energy. But where does that kinetic energy come from? In this case, you could add another transfer in that there is potential energy, gravitational potential energy in the reservoir, and it's falling down into the river. So you might want to say that there's gravitational potential energy to kinetic energy to electrical energy. Advantages, very similar to wind. It's renewable. It's not going to run out. No carbon dioxide, no greenhouse gases, no acid rain, no sulfur dioxide, no radioactive waste, and a short startup time. You can turn it on at the flick of a switch. Disadvantages, very limited location. You need rivers, but not just rivers, you need a particular shape of landscape that's going to be conducive to building a dam. And also not producing too large a lake that's going to be too disruptive. So if it is, then the wildlife can be affected. It's also very expensive to build a dam. There's the huge Hoover Dam near Las Vegas there. All right, wave power, a little bit different. It's not such a well known power source. It's not used as much at the moment, but it's sort of growing technology. But the idea, very similar, you've got waves. Waves are moving, they've got kinetic energy, and they will be on hinges, and those hinges will move around and turn turbines. So not quite the circular motion that you would often get with a generator, or a turbine rather, but just some sort of motion, again, moving in a magnetic field, is going to produce electricity. Renewable, no greenhouse gases, no acid rain, no radioactive waste, no land needed, short startup time again, easy to turn on, turn off, but not massively reliable. You don't know how many waves there are going to be. If there's a huge storm, then there might be issues, you're going to be damaging it, and you need a lot to produce a small amount of energy. So not used massively at the moment, but possibly a growing technology. Also you need to be careful about ships. You need to be somewhere where there's no ships likely to be going past. Right, the next one, tidal power. Tidal power, very similar to hydroelectric power. With hydroelectric power, of course, you had the water moving in one direction. You've got the river flowing downstream. With tidal power, the tide goes in and out. But the idea is very similar. You've got moving water caused by the tides going back and forth twice a day, and again, moving those turbines, which rotates the electrical generator. This time, again, you can think about it, what causes the tides? Of course, you've got the kinetic energy turning into electrical energy, but what causes those tides is largely the moon. Okay, the moon as it goes around the Earth, or as the Earth spins, the effect from the moon is affecting those tides. So twice a day, we're getting a tidal flow. So it's gravitational potential caused by largely the moon. To kinetic energy, moving the water, moving the flow of water, and then to electrical. So something like this, you would have in here lots of little turbines connected to generators, and the tide is flowing in and out, like a two-way river. There you can see it there as well. Very similar. Pretty much, obviously the designs can change, but this one looks pretty similar to a windmill. Yeah, the turbines are moving, they're just spinning around as the flow of the water occurs. Renewable, no greenhouse gases, no acid rain, all the usual stuff are the advantages. But the disadvantages, slightly different. Again, very limited locations where there's enough tidal movement. It's going to be quite limited. You've got wildlife potentially getting trapped in those turbines. Again, expensive to build, very similar to HEP, to hydroelectric power, I would say. Right, geothermal, however, is slightly different because you're not getting a flow in the same way. Geothermal is very similar to when we look at fossil fuels, we're talking about heating water, and it's that heating water that produces steam, and the steam is going to be moving and turning those turbines. So geothermal is going to be useful in certain areas where the Earth's crust is very thin. So where the Earth's crust is very thin, you have this hot magma or hot rocks quite close to the surface of the Earth. And if you force down cold water, that water is going to get heated. As a result, it's going to produce steam, and that steam at high pressure is going to be forced up into the power station, and that steam, that moving steam, is going to turn the turbine and turn the generator. But the process is the same. We've always got this generator moving as a result of a turbine moving. In this case, by forcing the steam through it. So this time our energy changes. We're starting with thermal. That thermal is heating the water is moving under pressure, so it's kinetic, and then again that's turning the turbine, turning the generator, and producing electrical energy. Advantages, it's really a very handy form of energy in the right place. Okay, it's completely renewable, no greenhouse gases, all the usual stuff. But also you can use that hot water, you can use that hot steam, you can transport it around villages, and you can use it as a central heating. So you're kind of getting twice the energy, you're getting a heating aspect as well. But very few places that this can happen. Iceland classically has probably almost all of its electricity will come from geothermal, but there are very few other places that it's useful. Quite expensive to build, but once it's up and running, pretty low cost to run. But yeah, just can't be used in many places, unfortunately. Okay, biomass is the most similar to fossil fuels, which we'll look at in the next video. Biomass is where we use burning, but we're not burning fossil fuels, we are burning any other organic material. So things like trees, wood, plants. We can make biofuels out of plants, we can make ethanol out of plants and burn that ethanol. We can use animal waste. All sorts of things we can use and burn it, and again that burnt material, this time we're going to use that heat to heat up water. We're going to use that water being heated to produce steam. The steam moves, it's forced at a pressure, high pressure, turns the turbines, turns the generators, and makes the electricity. So this time, slightly longer energy transfer, because of course the fuel itself contains chemical energy. Just like the food we eat contains chemical energy and we produce warmth, heat, movement for ourselves, the biofuels contain chemical energy. When you burn them, it's going to produce thermal energy. That thermal energy, as I say, heats up water. That water boils, produces steam, and moves. And it's that steam that is going to turn the turbines and the generators, ultimately producing electricity. So these biofuels, very dense energy, so you can get a lot of energy out of them. Really reliable. Okay, I can literally just have a store of ethanol or a store of wood. Whenever I want that energy, I can just throw it on and I know I'm going to get lots of energy. I don't have to wait for it to be windy. Considered renewable, even though you have to grow these plants, it doesn't take too long. Okay, so maybe it takes a few years for most plants to grow, maybe 10 years for a fast growing tree. So it's generally considered as renewable. It's also considered carbon neutral, which means although it's producing carbon dioxide, which is obviously not good for the environment, when we're growing these plants, they are using carbon dioxide because they photosynthesize. So the idea is they are offsetting. The carbon dioxide is offset. The amount of carbon dioxide they give out should be equal to the amount of carbon dioxide that they take in. So it's not, in theory, adding any carbon dioxide. It's just keeping it roughly the same. Disadvantages though, even though it's not adding to the carbon dioxide, we still get carbon monoxide, which is not good for us. We get nitrogen oxides and fine particles, which are just not very good for us, bad for asthmatics, and just not good for us generally. Sulfur dioxide, also we can get sulfur compounds in those plants, and that could contribute to acid rain. It also uses a lot of land, which could otherwise be used for livestock or food. Okay, two more methods for the renewable here. Solar heating, slightly different to solar cells. Solar heating is where you're using the sun's power to heat water. So again, you're going to heat that water, heat it up to a sufficient temperature that it's producing steam, and then that could generate electricity by moving that steam. But also, again, that hot water can be used to heat houses. So the heat energy from the sun is focused onto pipes, the water boils, producing steam, and the steam is then used to drive the turbines. You're probably seeing the same theme here. It's always just causing these generators to turn. So directly thermal from the sun, into kinetic, and then into electrical. Renewable, no greenhouse gases, no acid rain, and no radioactive waste. But you need a lot of sunshine. Not great in the UK, great in a desert. Only used during the day. Massive problem. It's not easy to store electricity, so if you can only use it during the day, that's not very helpful. A large amount of land, again, like wind power, you need a lot of space, you need a lot of sunshine to be falling on that area. Final one here, solar cells. Again, it's run by the sun, but slightly different process. So this time, solar cells are chemical. Certain chemicals will produce electricity when light falls on them. So the light is directly turned into electrical. Renewable, no greenhouse gases, no acid rain, no radioactive waste, instant startup time, but again, not useful in the UK. A lot of people, it's growing. There are more people putting solar panels on their roofs, but much better in hotter climates. Again, can only be used during the day. You can store it to a certain extent. It's hard to store electricity, but you can store it in cells or capacitors. And not massively efficient at the moment, but the efficiency is improving. Okay, so that is renewable resources. You should now be able to state 3 ways that energy resources are used, understand the terms renewable and non-renewable sources, describe, compare and evaluate the main renewable resources that we talked about. What are the advantages? What are the disadvantages? And also describe the energy transfers for each of those processes. If you want more information on tobytutorsphysics.com, have a look at those websites or that Facebook site there, and wait for the next video, which will be on non-renewable resources.